Hello and welcome to Rudy's Retro Intel channel. On today's episode, we're going to be looking at this Commodore 64. This poor thing has been electrocuted by the power supply, the stock Commodore power supply, which had a problem with one of his voltage regulators and completely fried the board. So let's peek inside, poke around, and see if we can fix this thing. Before we start the video, I just wanted to show you this is the power supply that is a Commodore brick for the 64s. I believe, yes, the Commodore 64 and the C64. These units are notoriously bad. The longevity of these things aren't very good. They're filled with epoxy. Inside is the actual electronics. And what happened in this case for this computer was that it looks like the 5-volt regulator just blew up and shorted inside. I believe it's the epoxy retaining a lot of heat so the parts don't last long. And if you have one of these, it's time to throw it away and get a new one. Don't use the power supplies. You can use a multimeter to measure the voltages out from the unit. If the power supply is producing roughly 5.1 volts, you're okay. If it's producing anything over 5.4 volts to 5.5, 5.6 volts, you better check it every time you turn it, before you turn it on. If it's over 5.6 volts, I would just chuck it. I wouldn't trust it anymore. I'd get rid of it. It's going to save you a lot of headaches and a lot of problems. There's a lot of people on the eBay and other places that sell Commodore 64 power supplies. So you're better off spending some money and getting a new power supply before you end up like my machine, which is totally fried. Okay, so this computer here, this VIC-20, it's 250425, had a incident with the power supply where the power supply just gave up and sent just over 5 3/4, 5.7 something volts through the computer and fried something. Now this computer's been on my bench, on the back burner of my bench for quite some time. I got it a while ago back. Didn't have time to fix it. I took out some of the RAM chips out of here for another project. This one too. I socketed this one. I haven't socketed these two. And I'm going to have to go through this again, check the voltages, and run a diagnostic, see if we can get something. Also, the PLA chip is located here. Some boards are located here, but only way to tell is to find U17. It's marked right there on this board. U17 is the PLA chip. And unfortunately, in this board, the PLA chip is not socketed, and neither is the ROM, CPU, and the CIA. The only thing that's socket is the VIC chip and the SID chip. So let's plug in diagnostics cartridge, see what we get. So diagnostics cartridge just plugs in the back. This one here is an interesting one. I got it off an Italian guy in Italy. 64 dual diagnostics unit. This cartridge is actually kind of neat because unlike most cartridges, you don't need to plug in cables. So for example, user port and your serial ports and the joystick ports, as you can see, don't have cables. A lot of units you have to plug in the units, which then has cables that run from there to your diagnostics harness. This one, you just plug it in and off you go. So for this initial test, you're not going to plug in the units, the adapters for the ports at this time. We just want to see if we can get some video. So let's turn it on. And I know there's no RAM chips here, so we should be getting a flashing of some kind to indicate that there is a problem with the RAM if everything else is good. So let's power it on. And as you see, we're getting one flash. All right, so that means that it's could be the RAM. For sure, it is the RAM, but it could also be the PLA chip. Because we're getting something, I'm gonna assume that the VIC chip is still good, but let's pull it out of the case, and I'm going to solder in 2 sockets here, populate the 3 RAM chips, and while I'm at it, I'm going to desolder the PLA and put in a socket. A lot of times the PLA chip is the problem. Okay, here we have the Commodore computer diagnostic spreadsheet that I've been working on for quite some time, and we have several tabs that are in blue, meaning that they are working or have data. The other ones are for future additions to the spreadsheet. I have one for the VIC-20, VIC-20 diagnostics, Commodore 64 information diagnostics, pet info, and pet diagnostics. What we're interested today in seeing is the Commodore. The menu, this particular section of the menu shows information regarding the Commodore 64 with dead test flash codes with regards to what flash codes are and what location the chips are in. If we go back and go to the diagnostics, I've selected them all, but I will show you all the information regarding the issues that I've found on Commodore 64s and what the possible areas to look at. So to make things a little easier, in this one we know that it doesn't boot, so there's no boot. Let's click OK, and here are the possible issues with the Commodore 64. PLAs are known to go bad. They're one of the most finickiest pieces on the 64. Also the RAM and some other logic chips, including the VIC chip, which runs the display. So let's get back to the board, desolder the PLA, put in a socket, and solder in some sockets for the RAM and populate those, and we'll run our test again. Okay, and we're back. So I have desoldered the PLA chip here, and I put sockets in the 2 memory chips right here. And on the back, it looks pretty clean. What I do is I use the rubbing alcohol with a toothbrush and a cloth, a old t-shirt. And I'll just show you real quick. Let me get my toothbrush. All right, so I use rubbing alcohol. This is 70%. This works fine. So what I do, I'll spray it on a section that needs to be cleaned. Then I'll take my cloth, I'll put on top, and I rub it with the toothbrush. You can also, if it needs really good deep cleaning, you can use a toothbrush to just rub the area, spray it again, and then use this to absorb. And it takes up all the dirt or flux onto the cloth and doesn't leave it on the board. So now that we have these in, before I do an actual test, I'd like to do a voltage check just to make sure that the voltage regulator, the 5 volts here and the 12 volts here, is actually producing the correct voltage, and then we'll throw in a dead test cartridge and see what happens. So let's plug power, turn it on. Let's see what kind of voltage. Hopefully you can see that. What are we getting here? So the 5 volts, 5.09, excellent. And the 12 volts, 11.95, good. So the voltage regulators are showing the correct voltage. Next will be to test that PLA I popped out and put in the RAM chips. So let's do the RAM chips first. Now, RAM chip number 1. Let's get this guy in here and get this other one in here. This one felt funny here. Let me see, make sure the pins are not bent. Sometimes you can put a chip in and the pins look, oh, it looks great, but the pins are all bent in and you're going, oh crap, and you spend an hour trying to figure out why it's not working, and then you find out that your chip is put in backwards. Okay, so this one's in. This is the SID chip, which we don't need to actually run the diagnostics, but we will leave it in for now. There are some new replacements, there are some replacements for the chip itself, and we'll probably do another episode to show you what alternatives we have for the SIDs. All right, let's fire this thing up. And we're not getting anything. Still no glory. We do get a flash on the screen. Sorry. We are not getting a video because there is no PLA. So let's put the original PLA in here and fire it up. Oh, we get flashing. How many do we get? Quite a bit. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so let's go to our diagnostics tests and the dead test cartridge information and take a look there. All right, to do that test, we need to pull out the dead test cartridge and the power, and I'm going to pull out the PLA. This one's a little stuck. The pin bends. No. Okay. So PLA. We will move this board to the side and bring in my diagnostics 64. I did a video on this in the past, a very short one, talking about how I converted a Commodore 64 to a diagnostics unit. And what I've done, let's open this up. We see that the sockets have been removed and the ZIF sockets put in. The ZIF sockets allow for easy access to the chips. You can just pull on the tab, chip pops out, put the new IC back in, close the tab, and run your test. So before we do that, let's run a diagnostics on this unit to make sure that the unit itself is working. So let's plug in our diagnostics cartridge. Video, and we'll do a quick test. All right, let's turn this on. And I am getting test results, although my capture card for some reason is flashing. I'm not sure if it's going to show up on the channel, but we do have some errors, and these errors are quite normal because the diagnostic cartridge has harnesses that need to be plugged in, which are not at this point. So we're not going to worry too much about that for now. What we're going to do first is pull out the PLA on this board here. Again, the PLA is U17. In this case, this board, this PLA is right here. And the board I am using is a very early version, which is a, let's see, where can I find it? The marking is somewhere on this board, and I can't seem to find it. 326 298. I don't think that's the number, but It's a very early board of the Commodore, Commodore 60, the Commodore 64. There was a lot of room to put sockets in, so it's a good board to do this because there's so much room to put zip sockets in everywhere. The PLA and the SID, there was no room to put it, so I just put a socket for the memory and the VIC. So anyways, let us pull out that chip. And plug in the other one. Let's see if it's defective. Again, make sure the notch is set up correctly. It's pointing in the same direction. And let's fire this thing up. Okay, so we are getting video. Let's see if I can see it better on here. And the video chip is good. Sorry, the PLA chip is good. Next, we will continue on with our diagnostics. Okay, with the diagnostics cartridge back onto this board, I'm going to put the PLA back in here. One thing I did forget to mention, I lost the video footage, but I did pull out the original PLA had a problem, and this is another known good PLA from my collection of Commodore 64 chips. So this is not the original PLA that came with this board, so this one was dead. Let's see if we get anything now with the diagnostics cartridge plugged in. Again, we're getting a flash, but this time we're only getting one flash. So what does that tell me? Well, that tells me that could be another RAM chip. Could be the multiplexers here. It could be really anything. I did notice that this machine, the kernel ROM, gets really hot compared to the other chips on here. So this is the chip right here, and I think it's going to be time. I think it's time to maybe replace that, because usually a hot chip indicates that there's something wrong with the chip itself. It's something inside is damaged, which is then just absorbing a lot more electricity than it should be and generating heat. So now it's time to pull out the soldering iron and pull that out too. One more thing I do want to mention is that with the dead test cartridge, not all the time that it's flashing, it's saying, oh, it's a memory error, it's a memory, and it can lead you down a rabbit hole. I've done a few repairs where I've had flashing codes from the diagnostics cartridge, and at the end it wasn't any of the RAM chips. It was a PLA. It was another case it was a CPU. Another case it was one of the ROMs. So although I have had repairs where it's just been a RAM chip replaced it and it was done, but the thing is not to rely too heavily on the diagnostics cartridge, because that could be wrong too. So in this case, I'm thinking I will desolder the kernel ROM because it's becoming really hot, and we'll go from there. Reason I'm going to be desoldering it too, you might be wondering, well, why are you sitting around desoldering all the chips and putting sockets? Eventually I'd like to have this all socketed, because this will become one of my own personal computers that I will keep for future videos, etc. And I would like to have stuff socketed, so for doing repairs in the future, if things break, it's so much easier to pull out the chip, do a quick test, and go from there. But in this case, it's such a pain. There's so many chips, if not all of them, or pretty much all of them, have been soldered to the board. And for some reason, this particular board, the solder used on it is very, what's the word I'm looking for, is very strange, in the sense that it doesn't, you can't suck it up properly when you're pulling out the solder with either solder wick or pump. For some reason it just really clings to everything, and I believe there's something not quite right with the solder used. I've done many boards and I've never had this problem, so I'm gonna desolder that and put a socket, and I'll show you what I'm talking about. Well, after hours of desoldering, chips testing, looking at documentation. I seem to have found this more and more. I'm not sure if it's showing up. There are so many traces being torn off, blown off. It looks like there's a lot more than just 5 volts going through this thing. And I've already placed the kernel ROM. I just did a test on that. That's bad. SID is okay. Well, I don't know why. The SID is fine, but the SID seems okay. PLA is bad. 2 more of the RAM chips were bad. The second multiplexer was also bad. The first one was fine. I'm not sure why one is burning the other. So I've decided that this board is now going to be a piece of wall art, I guess, because there's just too many things wrong with this. So the problem is that you have to learn to do repairs, but you also need to learn when to give up. And it's not the case of I want to give up. The case is that there's just so many things wrong. If I sit there and put all the traces, go through the whole thing, find every single trace that's now been lifted or damaged because of the voltage overload, I don't have the time for that. So this is pretty much the end of the video. I don't know what more to do other than put it aside. Maybe one day I'm bored and I'll want to spend hours going through all this. But for right now, I've already spent enough time on it. And that's all. Hopefully you've learned something today, and we'll see you in the next video. Take care.